All right, hey everyone. So this video we're going to talk about the discriminant and what it is and what it helps us to determine. And so for a quadratic equation, and this is the form of a quadratic equation, the quadratic formula gives us our solutions. So this is the quadratic formula. It is given to you. You do not need to memorize it. It will always be available to you, whether you're in the class or online. And the part that is under the radical, which is called that radicand, so that b squared minus 4ac, that is our discriminant. Okay, so the discriminant is the part of the quadratic formula that is under the radical. And so what the discriminant tells you is how many times your graph crosses the axis, the x-axis, right? And that's how many zeros, how many roots, how many solutions your quadratic equation has. And so if the discriminant is equal to 0, which means if b squared minus 4ac, when you substitute your values in, if it equals 0, then that means there is one real root. It means that your graph will only cross that axis, that x-axis, one time at one point, okay? If the discriminant is positive, that means that, and it's any positive number, right? Any number greater than 0, then you will have 2 real roots. That means your graph will cross that x-axis 2 times, okay? And when the discriminant is negative, then that means it doesn't cross. There are no real roots, no real solutions to this whatever your quadratic equation is. And that means that it doesn't mean that there are no roots, there are no solutions. It just means that there are no real solutions. And we know that when you have a negative under that radical, you're going to end up with an imaginary number. And so now we're going to look at some examples. Okay. And so let's try, I'm going to do a couple with you, and then I'm going to give you a couple to do on your own. All right, so let's start off with the quadratic equation x squared minus 4x plus 3 equals 0. And so you're going to start by just using the discriminant, right? We know the discriminant is written as b squared minus 4ac. And so first we need to clearly determine what is a, b, and c. So remember, this is really ax squared plus bx plus c. So c is your constant. So we know that c is going to be the constant, which is 3. Okay. B is negative 4. It is what is attached to x, or whatever the variable is that's standing alone with only an exponent of 1. And whatever is attached to your x squared, your coefficient, is going to be a. And in this case, even though you don't see it, it's going to be 1. So a is 1, b is negative 4, and c is 3. And so I'm just going to substitute these values into the b squared minus 4ac. And so this gives me, well, b is negative 4, so I have negative 4 squared minus 4 times a, which is 1, and times c, which is 3. Okay, and this part you can put right into your calculator and get your value, and it's going to be 4. And so 4 is positive. 4 is greater than 0. It is positive. So there are 2 real roots. Okay, it means that my graph will cross my x-axis at 2 different spots. Okay, this is number 1 from section A. I'm also going to look at number 3. And so if you look at number 3, you have, you have negative 2x squared plus 4x minus 5 equals 0. And once again, we're going to just determine what a, b, and c are. So a is negative 2, b is 4, and c is negative 5. And I'm going to use my b squared minus 4ac and substitute in. Okay, I'm going to use my b squared minus 4ac and substitute. And so what it will leave, well, b we know is 4. So I have 4 minus 4 times, well, a is negative 2 and c is negative 5. Sorry, we got an extra set of parentheses there. And when you simplify this, you end up with negative 24. And so what that really means is under my radical, there's a negative. And we know that we can't have a negative under my radical, right? And so it doesn't mean there are no solutions. It means there are no real solutions. Okay, it means if I do have solutions to this, they are in the imaginary realm. So this does not have any real solutions. My graph does not cross my x-axis at all.